Welcome back. Problem 11-37. So statement is determine the height h of rectangular cantilever beam of constant width b in term of h naught, L and x so that maximum normal stress in beam is constant throughout its length. So you can see this is the cantilever beam that is acted upon by uniformly distributed load, that is W. The length of this beam is L. This is at the end height is equal to h naught, and this width b is constant throughout the length. So you have to find this h in term of other variables. So condition is maximum bending stress is constant throughout its length. So let's start with the solution. So we know that maximum bending stress is equal to moment divided by section modulus. So we will find first moment. For that we will cut the beam at distance of x from this end, and we will draw the free body diagram in order to get the equation of bending moment. This is not so this is the beam, and we have a distributed load over it, and this distributed load is W. The total length of this beam where we have cut it is x, and this is W. And when you cut the beam over here, so definitely you will be having a shear force, reaction shear force, which is V, and you will be having a bending moment, that is M. Let this is 0.1. So now we will apply equilibrium condition that sum of all moments about 0.1 is equal to 0. So you can see about 0.1, one moment is due to this distributed load when converted into point load. So it will be W into X, and that will be acting at a distance of X by 2. And the moment will be clockwise, so that will be negative. The second moment is external moment, reaction moment, which is M, that is counterclockwise. So their sum must be equal to 0. So M is plus minus this moment when converted into point load, it will be W into X, and that will be at a distance of X by 2 from either side. So W into X is force and perpendicular distance is X by 2. Their sum must be equal to 0. So it means that moment is equal to Wx square over 2. So this is the equation of moment for this beam. Now we will find section modulus. So section modulus S is equal to I divided by C. So what is I? I for the beam that is cut over here. If you draw the cross section, so it will be height will be h and width is b. So I will be equal to 1 over 12 bh cube, and what will be c? So c will be equal to half of h by 2, h over 2. Okay, so when you put it in this formula, s is equal to 1 over 12 bh cube divided by c is h over 2. So this will be equal to bh square over 6. Now you can put it in this formula. So you will have maximum bending stress is equal to moment, which is Wx square over 2 divided by section modulus, which is 6h square over 6bh square over 2. So there is a b as well, bh square over 6. This is formula, bh square over 6. You have to remove this, bh square over 6. So when you solve it, you will get w x square into 3 divided by bh square. So this is the bending stress. I will write it again, 3wx square over BH square. So this is your equation number 1. Now you can see that what if x is equal to L. So if x is equal to L, then we will have this height is equal to h naught. So we will replace it. We will write over here. Okay. So at x is equal to L, h will be equal to h naught. So if you can put it in equation 1, put in equation 1. So we will have maximum stress is equal to 3W L square over BH square. This is equation number 2. Now maximum stress is constant throughout length. So equation number 1 is equal to equation 2. So 3WX square over BH square is equal to 3WL square over BH square. So from here you will get this first one is this is h naught because we have replaced it with h naught. So you will get h will be equal to h naught over L into x, because this will cut with this b will cut with this, and we will have h square is equal to h naught into x over L when you take under root. Let me do it also. So okay, so let me do it for you. We will have h square is equal to h naught square into x square over L square. So h will be equal to, if you take the under root, it will be equal to h naught into x divided by L. So this is the answer. I hope you have enjoyed this video and you have learned it as well. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.